Hello, continuing on in our probability unit. This lesson is on sample spaces and fundamental counting principle. Sample space is the set of all possible outcomes or results in an experiment. So last lesson was a simple event, one event happening with one outcome. This is the all possible outcomes. We use two different methods for finding sample space, tree diagrams and fundamental counting principle. A vendor sells vanilla and chocolate ice cream. Customers can choose from a waffle or sugar cone and either hot fudge or caramel topping. Find the sample space for all possible orders of 1 scoop of ice cream in a cone with 1 topping. So we have all different options, or all different total possible outcomes of leaving with our choices. So we can have vanilla with a waffle cone and hot fudge. We can have vanilla in a sugar cone with hot fudge. We can have vanilla in a waffle cone with caramel, and we can have vanilla in a sugar cone with caramel. We can have chocolate in a waffle cone with hot fudge. We can have chocolate in a sugar cone with hot fudge. We can have chocolate in a waffle cone with caramel, and we can have chocolate in a sugar cone with caramel. We'll make that CH for chocolate. Okay, the sample space is all possible orders, so how many total different orders are there? So then we look here and we just count. We have 1, 2, 3, 4, 5, 6, 7, 8. So the sample space of this situation is 8 total outcomes, meaning 8 of us could go in there and leave with all different choices. Okay, so here's another situation. The animal shelter has both male and female Labradors in yellow, brown, or black. Find the sample space for all possible Labradors at the shelter by creating a tree diagram. So instead of creating a table like we did with the ice cream cones, we're going to do a tree diagram, which is a little bit easier and less work than a table. So we first can choose between male and female, and then we choose between yellow, brown, or black. So what we're going to do is our first choice is male or female. And then so we can have a male yellow, male brown, or male black. We can also have a female yellow, female brown, female black. So the sample space then, this time we just count the whole right side, and we can see that because this right here is a male yellow. This is a male brown. This is a male black, female yellow, female brown, female black. So we have 1, 2, 3, 4, 5, 6 total outcomes. Okay, let's try another tree diagram. You go golfing and have so many options. You can pick between a white, pink, or yellow ball, and then you choose between your driver or putting wedge off the tee, and then you can either walk or ride in a cart. Find the sample space by creating a tree diagram. So our first choice is white, pink, or yellow ball. My second choice is going to be added on to each one between the driver or pitching wedge. So that means we're going to have 2 lines coming out of each of the balls, okay? Because then we're going to choose between our driver or pitching wedge. Driver, pitching wedge, driver, pitching wedge. So far we have, like right here means that I chose a white ball and I used my driver. Right here means that I chose a white ball and used my pitching wedge. Here it's a yellow ball with my pitching wedge. Okay, so then our last choice is walking or riding in a cart. So from the driver, I'm going to have 2 more lines. So walking or riding. Walking or riding. Notice it comes from each choice in the column. So it starts getting a little cramped in there. And I'm adding that from each one. Okay, so now if I look, and let's just say we pick one and we pick this option, oops, I meant to go down there, means that I picked a pink ball, my pitching wedge, and riding in the cart. If I pick this one, that means I picked a yellow ball, I'm gonna use my driver, and I'm gonna walk. So see how they all are different options. So now we count our last column and we count how many outcomes there are. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 total outcomes or options from the choices that we can pick. Then it says, what is the probability of picking a pink ball using your driver riding in a cart? So pink ball, driver, riding in a cart is right there. That's one of my outcomes, just one, right? So that would be 1 over the total number of outcomes, which I just said was 12. So the probability of that would be 1/12. And then if we want to write it as a percent, we do 1 divided by 12. And we get 0.083. We'll round it to that, so it would be 8.3%. Okay, we're going to do one more example using a tree diagram. Marco tosses 3 coins. If all 3 coins show up heads, then Marcos wins. Otherwise, Kara wins. Find the sample space and then find the probability that Marcos wins. So I'm going to write my columns. So if he's tossing 3 coins, okay, as my tree diagram, just so we remember, this is going to be my first coin, my second coin, and my third coin. So the first time I flip my coin, I can get heads or tails. The second time I flip for the next coin, I still can get heads or tails. So I'm going to add that on to each of my previous options. And then the third time, I can still get heads or tails, and that's going to be added on to each, again, of my previous options. So notice I'm adding it and keeping it as nice and organized as I can from there. Okay? And then it says, if all 3 coins show up as heads, then Marcus wins. So right here, I'm going to try to get my highlighter. This is heads, heads, heads. All 3 are heads. That means Marcos wins. Okay? The rest are not all 3 heads, right? Because if we did this, that's tails, heads, heads. Here is tails, tails, tails. Even down here is heads, tails, heads. All different options, right? So remember, we look on the very right column that we end with. We count how many outcomes there are. So 1, 2, 3, 4, 5, 6, 7, 8. And we said that there's one option of heads, heads, heads. So the probability of Marcos winning, is 1 out of 8, because there's only one way that the coins can fall of him getting heads, heads, heads out of 8 total outcomes. So that means the probability of Kara winning would be 7 out of 8, or 7/8. So Kara has a lot better probability of winning over Marcos. Okay, so then we get some situations where even drawing a tree diagram is so much work. So there's something way, way, way simpler, and that's called the fundamental counting principle. And the fundamental counting principle states that if event 1 has m possible outcomes and event 2 has n possible outcomes, then event 1 followed by event 2 has m times n possible outcomes. So what does that mean? Find the total number of outcomes when a coin is tossed and when a die is rolled. So a coin is tossed, so if a coin is tossed, we have two possible outcomes, either heads or tails. If a die is rolled, we have 6 possible outcomes, right? 1, 2, 3, 4, 5, or 6. And then we multiply those together. So this is my coin outcomes. This is my die outcomes. So 2 times 6 would be 12 total possible outcomes. A little bit easier than doing the tree diagram that way. So we'll look at some more situations. The jeans shop sells jeans in different sizes, styles, and lengths as shown in the table. Find the total number of jeans available. So we can look at the size, length, and style. And then we just multiply to find the total number of jeans, like possible options. So like how many different sizes there are, how many different lengths, and how many different styles. So we can see that there's 1, 2, 3, 4, 5 different sizes, and then 3 different lengths, and then 3 different styles. So then we just multiply that together. 5 times 3 is 15, times 3 would be 45 total possible, and we could say total number of jeans or just outcomes. So again, remember this is the sample space. The sample space is how many total possible outcomes are there. And then find the probability of getting a 32 by 34 slim fit. So 32, 34 slim fit is just one of the choices out of the 45. So it would be 1/45. And then let's make that a percent. 1 divided by 45, 0.02222. So then it would be, we would round it to 2.2%. So the probability of getting this exact pair of jeans is 2.2%. When we talk about the number of outcomes when a coin is flipped or a die is rolled, then it gets a little bit more confusing. So find the total number of outcomes when a coin is flipped 3 times. Okay, so we need to think about how many possible outcomes there are each of the 3 times, and we multiply that together. So if I flip the coin 1 time, I know that I can either get a heads or tails, so there's 2 possible outcomes. When I flip it again, I can still only get 2 possible outcomes, heads or tails. And then I flip it again, and I still am getting either heads or tails, so 2 possible outcomes. So then we multiply it together. 2 times 2 is 4, times 2 is 8. So 8 total outcomes. The 3 is just telling me how many times I'm going to multiply that together. I'm not actually multiplying it by 3. Okay? And then find the total number of outcomes when a dice is rolled 2 times. So roll number 1, we have 6 different outcomes. 1, 2, 3, 4, 5, 6. So that's going to be 6. And then if I roll it again, we still have 6 different outcomes, or 6 different numbers that could land. And that's 1, 2, 3, 4, 5, 6. So 6 times 6 is going to be 36 total number of outcomes if I roll it 2 times. John is taking a true-false quiz. There are 4 questions. How many outcomes are there? So 4 questions means question 1, question 2, question 3, question 4. And we'll do that. Number 1, number 2, number 3, number 4. So we ask ourselves, how many different outcomes are there on question 1? If it's a true-false, there's 2 different outcomes on question 1, either true or false. So that'd be 2. And then on the second question, it's the same, because it's either true or false, and that's going to be the same for all of them. So we would do 2 times 2 is 4, times 2 is 8, times 2 is 16 total outcomes. So you have to stop and think, and I think it helps when you draw out your lines for each question or roll or flip or whatever, so you know exactly what the outcomes are for each one. What is the probability all 4 answers will be true? So that means that it would be true, 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 which is really the only way that it could go. So that's just 1 out of the 16 total outcomes. So the probability of all true would be 1/16th. 1/16th. Then if I do 1 divided by 16, I get 0.0625. So we'll round that to 6.3%. I want you to pause the video and do these questions in your notebook or in your packet, whatever you have, and then come back and check your work. Okay, so if you're ordering an entree, 1 side and 1 dessert from the menu to the right, find the sample space for the above problem. So the sample space would be doing a tree diagram with the entree, side, and dessert. That would be a good practice for you to do in your notebook. I just didn't do it for this problem. How many outcomes are there? I did 3 times 3 times 2 because there's 3 entrees, 3 sides, 2 desserts to choose from. So I got 18 total outcomes. And then the probability of chicken, fries, and pie, so that's just 1 of the outcomes, would be 1/18th, which is 0.056, which rounds to 5.6%. Secondly, if you're buying a hockey jersey with the choices of green, blue, or white, and sizes small, medium, large, extra large, I did the sample space here. Sample space, remember, shows all of the outcomes. And then, and so you can see I did my tree diagram. First, my first choice is green, blue, or white. Then my second choice is small, medium, large, extra large. What is the probability, or how many total outcomes are there? There's 3 colors, 4 sizes, so 3 times 4 is 12. And then the probability of green medium would be 1/12, 0.083, and then 8.3%. That's all I have. Have a great day.